Let's look at our normal stress. And I have to change that to the Y direction. All right. So if you watch the previous notch bar video, we calculated that this stress concentration factor was about 3. And so for an applied normal stress of 20 KSI, that we're getting the what we would predict with our hand calc. And we see that because we're running the linear material model with no plasticity model, we're getting a stress in the notch that's higher than our yield stress. And if we look down, our plastic strain should be 0, and it is. And the total strain will be equal to your equivalent elastic strain because there's no plastic, we're not modeling the plasticity. Now to view the symmetry with the beta version, you go over here you click on symmetry, and then number of repeats. Okay, so I had to change the number of repeats to 2, and then the method you change to half, and then you have to put a tiny delta x in the normal vector of your symmetry. And we see here that the symmetric mesh shows up. And then if we look at our stress results, we'll see. And you can see how the bar deforms when we pull on it. And that makes sense. So it's this is opening up. So if you think about each kind of plane going in the x direction, each little YZ plane, because we remove material here, this section won't be as stiff as the middle section. So the outer part of this bar is going to want to deform more than the inner part, and you see that it ends up kind of looking like a mouth opening up. So now we can run the plasticity material model. So what we'll do is we'll go back to part, and we'll change our material model to aluminum alloy nonlinear. And then all you have to do is click solve. And it's solved. So now if we look at our normal stress, we see that it is lower than our elastic stress. Because essentially what's happened is the notch is strain hardened. So it has yielded, so the strain material has taken up the elastic stress, I guess, stress energy, and it's yielded. So the strain has increased, and the model, and it's you know strain hardened. And I'll talk about the results in the next video. We'll go into some theory on how you can calculate the new stress, the stress from something called Neuber's rule. But if we look at the equivalent plastic strain, we see that it's plastically deformed in the notch and strain hardened as a result. And we see the total strain is the sum of the equivalent plastic strain and the elastic strain. And you can see here the strain in the model, the elastic strain in the model, and then the plastic strain in the model. So this is the region where it deformed locally. And that's what we would expect. Now we can animate this. So you can see as the load is applied over time, the notch starts to deform. Yeah, so that's how you run a plastic analysis in ANSYS. And thanks for watching, everybody, and looking forward to making more videos. In the follow-on video, I will go over the theory of the some of the plasticity theory and calculating this, how you can calculate this or approximate this by hand. So thanks for watching.